All right, so we'll get things started. Just first of all, Jacob is very nicely staying at the office after hours. He's also drinking a beer after hours. He's allowed to. But so you have to kind of appreciate that he's doing this on this Friday afternoon, evening. So thank you all for being here and giving him a really good audience. So with that in mind, please turn around and wave at the camera for him so he knows there's actually people here. Hopefully you can see that, Jacob.
Yes, I can see you all.
Excellent. So yeah, Jacob Jenkins, he's a former student of mine. I taught you for a few years in varying capacities back at VW New Zealand. And I still to this day have this remarkable memory of you just having such gusto in manipulating contours on the Hutt River. You just went like a madman at those things. I've still never seen a student quite do that with the same energy, just diving into a real kind of serious topographical manipulation. And I think that kind of speaks to your character as a designer. You just really love to jump in and try new things. And this drone stuff is exactly in line with that. He kind of really set up the drone kind of research program at VW alongside Peter Connolly, myself, and he really left in good stead. We moved to practice and then moved back to the UK. How long have you been in the UK now? About 3 or 4 months?
Yeah, 2 months, 3 months.
Yeah. With that in mind, how about you? I didn't do justice to you, so maybe give yourself a short introduction and then jump into what you've got to share with us.
Yeah, so for those who don't know me, my name is Jacob Jenkins, and as Sean said, studied at VEW, bachelor's and master's degree there, and taught by and worked alongside Sean for many years while he was doing his PhD, while I was doing masters. And I'm sorry, stuff coming up on the screen. And yeah, took a strong interest in how drones could assist us in landscape architecture. It just seems to have that easy ability that what it produces for us is just an asset. And so kind of really got the ability to really test some things which I'll be going through, so I won't give too much away in that, but yeah, kind of learned a lot doing that myself in that first year, and then professionally working at my previous work in New Zealand, 3-4 years as a drone operator as well as a landscape architect, and really learned a lot along the way, and it's been really good to see the VEW program go strength to strength now with their big boys that they've got now drone wise, so it's good to see.
All right. I'm pretty sure I've got things set up that you can share your screen, but give it a go, and then floor is yours.
Marvelous. Let's see what happens. Does that come up for everyone?
Not quite yet. Give it another go. Oh, there we are.
That now working.
Yep, we're good now.
Yeah, and if I bring up this file explorer, come up and then disappear again.
That's it.
Go. Excellent. You happy for me to go?
Go for it.
Sweet. So tēnā koutou katoa, ka upuku te moanga, ko raka te awa, ko Jenkins toku iwi, no te whanganui a tara ahu, ko Jacob Jenkins toku ingoa. So good morning, good evening, midday, wherever and whatever time it is for anyone here. Just an introduction, mihi, te reo, just beforehand. Just naming some of the key kind of areas that represent who I am. So my mountain, Upuku, or Mount Hutt, where I grew up in New Zealand, in mid-Canterbury, the Rakaia, main river, again in mid-Canterbury, main waterway. Jenkins obviously being my family name. And I recognise Te Whanganui Atara, or Wellington, is my kind of home. It's where I lived, studied, worked for the last 8 years. And my name being Jacob Jenkins. So yeah, today looking at full screen going. So what I deem I call a shift in modality, and this, I suppose, this is an ongoing shift in modality. The original name coined about 5 years ago for thesis works back in 2019, 4 years ago, and it's looking at the extractions and processes of UAV, drone data, and landscape design. So just a brief introduction, kind of gone over this already, but let's go over again. So did my studying at Victoria University with some brilliant people such as Sean and Peter. And my areas of interest, landscape architecture, urban design, doing the visualization and graphic communication, Revit, CAD, construction detailing, but also UAV, RPAS, photogrammetry, to an extent LiDAR. I'll go through these in more detail, and landscape design. So I've been practicing now as a landscape architect professionally for 4 years, both in Aotearoa, New Zealand, and now the United Kingdom, and 5 years experience in total operating fixed wing and quadcopter drones in various methods and RGB or standard color camera, photogrammetry, multispectral, LiDAR payloads, and data outputs. So just the map on the right-hand side is the various locations that I've done drone work with my previous work, Boffin School. So it's just really taken me to almost all corners of New Zealand, doing all sorts of various projects for landscape architecture, planning, urban design, and I've really kind of ramped up my experience by undertaking all of these various projects and different agendas that each project has, and utilizing the drone for the project's outcome. So split the presentation into a couple of parts. So part one, kind of go through, what is a UAV drone? I'm sure most of you do know what they are these days, but I'll go through the basics. Kind of typical outputs, pardon me, and how does this assist landscape design, being the crucial part. So what is a UAV and what is photogrammetry? You'll probably see lots of pretty pictures of drones. These are some of the flying, as I coined, big boys that I've used. It's a fixed wing drone that we used at previous work, all the way down to smaller Mavic units. So UAV stands for an unmanned aerial vehicle, more commonly known as a drone. And so the drone is a vehicle that has this ability to fly itself on automated, predetermined flight plans with given distances and heights at incredible accuracy that's much more capable than us humans could ever hope to dream of. It can be instructed to do all of these things, and can capture targets for various outputs, as I mentioned before, right from typical cameras, multispectral, which is basically a normal camera split into the color ranges, more for plant work, and then right into LiDAR, which is light detection and ranging light scanner, which essentially allows much more detail that you can gather of the information you're scanning in photogrammetry. And you can then convert these outputs into various 2D and 3D geolocated outputs useful for projects. So what is typically produced? So from photogrammetry, you can see on the left a series of photos that are produced from the drone when you fly over a site. You get an orthomosaic or aerial map, very similar to satellite imagery, that's stitched together to give you an updated aerial view of your project. You'll also get a 3D mesh, various uses for that. Myself particularly, I don't personally use it too much, but if you're the kind of person who loves using meshes for various processes, that's very useful there. There's a rendered point cloud. So in the name, it's a cloud made out of millions and millions of points. And I'm not joking on that, it is millions. Tend to be quite big databases, but hold incredible value of data, not just depending on obviously what kind of modules you're using. It doesn't just hold a color of RGB significance, or the color of, true color we see with our eyes. Can also hold other information, can hold classifications, what's ground, what's tree, what's road, what's water, and can hold other pieces of information such as elevation. And then there's also DSM or DTMs, digital surface models and digital terrain models. This is all mainly derived based off the point cloud through a series of processes that will give us ground surfaces and also just a surface in general. And then also from that, we can generate typical contour information, useful obviously for representing mapping aspects. So these are just, these are some extracts from my thesis when I was first kind of looking at, what does the drone offer when you're scanning a site for a start. So it obviously produces highly detailed areas of the ground of what you're looking at, allows you to cut into whatever and whenever you think that you're looking for, ability to create those sections really quickly, and you can kind of really easily scan around in a three-dimensional manner. It's really useful for mapping unmapped spaces and potential experiences. Obviously, there are some sites that are just really hard to actually physically get to that we just can't get. And so the drone allows, on the assumption you have all the permissions set in order, you can scan areas that you can't otherwise physically get to, and you can then use that as a base of information to kind of understand or begin to understand what sites are like. There's also the ability of some areas, again, similar to areas you can't physically get to, but just areas in general that are difficult to get to. Things like items underneath water, for example. Very tricky thing to do. Have to have a lot of particular elements going your way, flat water, height and date of time. But did find out through some testing that it was actually possible to get some riverbed information looking underneath the water's level there. And another thing that was quite crucial that the drone allows is you'll see the sections on the left-hand side there. So the top section is from a surface derived from drone material. And then the same location down below is surface information derived from what council data was available at the time. And that council data would have most likely been flown by satellite or earlier data that was not as detailed as scanners are now. And so you can see quite a clear, distinct level of detail and accuracy in the river edge there and what you're able to pick up. So again, as I say, you can be very site specific. You can range from a large area right down to a small area of what you're particularly looking for, which means you can really start to pull out some of the interesting bits that you're finding is particularly important, maybe for a project. Could be landform, could be rivers. In this case, it could be riverside. Experiences and qualities and various others. We'll go into further detail on how all those work. So why drones? Why landscape? So I'd argue the drones have been around now for a wee while, and they've developed into these really highly sophisticated technologies. And they have a lot of uses in various fields, but as well as in landscape architecture. Now, I would personally argue that, as I said earlier at the start, the landscape discipline has a natural calling to the usage of drones. They allow us to capture and map, the landscape realms. Oops, sorry, TV's warning it's going to turn off. I don't want it to do that. Sorry. As I say, they allow us to capture the landscape with mappings and 3D outputs that are associated with drone operations are easily an asset to landscape, point clouds, the aerials, contour information, etc. So the majority of the time, especially maybe professionally or commercially, drones and photogrammetry in landscape design or landscape works in general tend to focus on visualization, because it's really good at doing that, and techno-scientific problems. However, in contrast, I personally believe as a designer, and it was deemed kind of a major tendency that occurred in the field of landscape, that the drone has the potential to assist understanding large landscapes and human life on the ground together. So large landscapes are really difficult undertakings to kind of wrap your head around. They're so big and large, and they hold all of this, how we experience the world, how we experience landscape on a day-to-day basis, what is deemed a life on the ground. So that spatial experiential relations that we have with the landscape as we move through it. And to try and understand that kind of level of detail of how something is kind of making you move through a space, or kind of your sensory aspect, trying to do that over large landscapes, kilometers of space, is really, really hard. It's a difficult thing to kind of portray and do. So some of the works here propose that drones and photogrammetry may have the ability to produce representations, mappings of the landscape, which do capture, on the one hand, that kind of life on the ground, human body relation to the immediate landscape, but then actually correlate these to the larger scale relationships of large landscapes. And the idea of that, meaning that the designer should then be able to work between the two much more readily, and actually then critically inform design moves based on actually how we are moving through that space, but over a large scale. So henceforth, the extractions and processes in response to this landscape tendency is what is of significance. So yeah, as I say, is there another way? Was kind of a key query when I was looking at this for thesis. Something that will tackle that difficulty of understanding and forming mappings and representations of what happens life on the ground, but for large landscapes. And so is there the potential for drones to do this? And the main value that the drone has is its ability to do both the small and the large, as I said before. You can fly and do a survey of kilometers of area within a day and have all of that data in both aerial, 2D outputs, 3D point clouds, etc. But you can zoom into the finesses of the details. And so you've got that ability to kind of zoom between the two without losing out on accuracy and detail. And so critically, it's how can we then take that data and kind of explore with other conventional methods in landscape architecture, both analysis and design, to kind of utilize that. So, you might be thinking at this stage, it's all just pretty pictures and lots of clouds with points on it. But as I say, the main thing here is, how can the data from the drone be extracted in a meaningful way that, from what we extract from landscapes, especially dealing with the large and the bodily scale. So the following slides, a handful of extractions and processes, I think that were pretty critical in kind of understanding the site at hand, which I'll go through shortly. So part 2, extractions and field studies, followed by experimentation and landscape design. Kind of the meat of everything here. So the site that was chosen for this study when I was doing this was the Tiawa Karangi, or the Hutt River. It's a braided river based in Lower Hutt and Upper Hutt, about 10 and 20-minute drive north of Wellington. And it's a massive riverscape that, is used by lots of people every year. If I recall, I think it has 1 million cyclist users every year because it's part of the Hutt River Trail. So this is a serious space where a lot of people will use it as kind of their, escape the city, suburbia, and kind of get out and about. And so, why riverscape? So riverscapes are large pieces of landscape that we experience on a daily basis. It incorporates both the big and small scales, as it's kind of a space that is consistently changing with vegetation, movements, bumpy things, technical aspects, flooding, spatial areas, ecologies, and just a general change of movement over time. It's just what seems the perfect site to kind of really start to test whether the drone would assist in understanding these kind of nuances of these river scapes, those pulls and shifts of the landforms, things like trees and rocks, views, orientations, those really bodily related items. But could it then do that over a large landscape scale without kind of forming into a generalization and losing the kind of key qualities of the bodily experience in a river. So this is a small example. It was kind of trying working out the scales. You know, if the process worked at a certain scale, could I then push it onto another scale? So this was an intermediate scale of what I deem tree worlds, and the Hutt River is full of what I call tree worlds, and how looking at extractions. So these tree worlds, they are all along the Hutt River, and they are mainly there for a technical aspect. They are there mainly willows, but now becoming much more native plants in there as well, as bank, for bank control, stopping erosion, because the river is this moving beast as it goes down towards the harbour. And so there are various amount of these kind of stands of trees running all the way along the site. You can see just this extract here. This is about 6 kilometers worth of the Te Awa Karangi. And they're just essentially trees running all the way along, right up to the banks on either side. And this is really unknown kind of space because, as I say, it's there for technical aspects more than anything. So it was kind of decided, how could it kind of tap into some of these aspects of the Hutt River. So the study was looking at two things: the spatiality and movement of these willows, and their kind of variances, and then the relationship of the user within these tree grids and the other surrounding elements like the road, the river, and actually what makes these spaces tick and do and what they make you do. So, so one of the key things that kind of came out from this mapping exercise was the drone material offered such a high degree of detail that hadn't been available beforehand. Previously, to get kind of an idea of the green massing of these kind of tree belts, you rely on satellite imagery, Google Earth, any council data. And by the time you zoomed into that kind of detailed scale that relates to the human bodily scale, it just became a big green blob. And so when did this first mapping exercise with the drone, you could actually start to pick up the individual trees and movements. And so through this mapping exercise, started to actually understand, okay, what direction are these grids moving in? What is the difference when the grids tighten up, open up, different direction change? Does that actually have an impact as you're moving through those spaces? And so that, together with typical standard field studies, usage of photos, diagramming, understanding where the edges and shifts change, actually started to reveal kind of some typicalness of a certain kind of tree world, grid size, angles, etc., made a certain kind of movement through those spaces. So you can see here, like there's the edge of the trees on the riverside. Only here the river can be sensed, and it was very rare that the river could be sensed purely by itself, because things like the road and other aspects were highly dominant in this kind of space. And so you could start to find these kind of tipping points of when the trees had done enough in terms of the grid angles and accurates, that it would actually mean you totally became embroidered by the river and kind of forgot about the other kind of landscape aspects, such as the road and pathways and other things. So it was because the drone data detail allowed us into that. It helped kind of step into that world and actually start to extract those key things of what it was that made you as a user kind of move through these spaces and what you got out of it. So you can see on the left, the high detail that the drone imagery was gathering. Each individual tree, sensor shadows, and the size of canopies, etc. You could start to kind of feel where the clusters were tight, where there are openings. Whereas on the image on the right, the trees are much more, it's a grainier image because the detail, the accuracy is just not there to the same level of detail. And so you'd be assuming much more in this example. So it was kind of that ability, as I say, to take the detailed drone material and start blending it in with field studies of actually what was extracting from experiences you're starting to extract from those understanding of those tree grids and worlds, and then trying to move it up to a larger scale to try and utilize what the drone data was giving, as well as what I was kind of understanding this landscape did. So this is called the Werrison walking. Various times we've walked this space. I don't know how many kilometers Sean and I have clocked doing this, but this is one image at one end. As you can see, it's a very kind of standard. It's a pathway. There's some berm either side. There's a main road, 70 km/h, so it's very kind of dominant roading area. And you can see the path just gently meanders along. Nothing really changes. Trees to the left, road to the right. And then this is an image about a kilometre and a bit further down. You can kind of see, to be fair, not a lot has really changed in the great scheme of things. Suddenly the river is there because there's no trees. But apart from that, it's very similar. And so generally, as I say, generally, you kind of form into a form of generalization that it's just the same all the way along. Path, road, bit of landform on either side, and some group of trees. But what this was trying to understand was, this is a wearing kind of walking. You kind of start, you understand that the dominant road to your right-hand side is really there, noise channeling away. Group of trees, sometimes really thick, so you don't really get a sense of the river. And so you kind of, you suddenly become autonomous. You turn into an automatic mode as you travel down this space. And so there was more to that space that it could kind of tap into to understand. So there's the kind of current pathway that does meander gently. There are subtle shifts in the landform that move along, and the drone data kind of helps pick that up. More use in the design stage, which I will go through shortly. But the ability to use the drone material in a large scale sense as well, just to assist understanding those kind of gentle topographical changes. You can see with the point cloud 3D output here, it works as a great base to kind of start to diagram over the top at that larger scale, kind of pointing out that, majority of the time there's no view through to those tree areas into the river, but there's those subtle shifts in the landform. And so understanding those subtle shifts, the landform moving just enough in height that perhaps the noise of the road decreases significantly, then means your sensory, activates more to the river or other aspects of the river. So it really helped to be able to diagram and show this at the larger scale, but then also again undertaking a similar process to the example beforehand of using the highly detailed information that was coming from the drone. So again, extractions of passageways, main kind of grid tree angles and distinctions between them, where the trees would tighten up to a point where there was just no way through to the river, or they'd spread out enough that you could perhaps walk through there, but it would be tricky, right to the point where it's kind of really easy to walk through those spaces, or it's actually inviting to come down there. You have passageways which are actually clear-cut alignments to the river. They offer a moment to the river rather than the road and other things around you. And so it's just trying to extract all of those, but then also understanding it from actually going through those spaces, documenting it with photos, diagrams. There's these moments of, can the road be seen? Can the road be heard? Can it be sensed? And then can the river be also seen, heard, and sensed? And there's all these, as I say, these tipping points of a certain, as I said before, kind of tree grids, the densities, the type of trees, length of grass that you're walking through, the ground surface texture in general, kind of that level of detail of the things around you that make you move through these spaces in a certain way, kind of dictate then how you're moving through that space. So through these processes that were kind of tested out, it became clear that, you know, the detail of the drone material, the clarity of textures, elements of the landscape at that bodily scale, trees in this particular example, were really a winner. It kind of really helped out extracting those kind of understandings of how those spaces seem to work, which would be crucial, you know, moving into the design. But it's, I think, important that it doesn't do it just by itself. It is that integration of drone material and field studies, on-site experience through that kind of spatial and temporal time, usage of photos, sketches, mappings, diagrams, anything that kind of helps assist extracting the elements that you're looking at. Or in this case, it all kind of added up to extracting the logic of how this riverscape worked. You know, the extraction of why and how the user experiences the site in a particular way, and that kind of bodily detail could then kind of start to be understood over a large scale. Basically taking bits of the river, because obviously it would take a long time to intrinsically look through the entire 6 kilometers worth of space at that level of detail. You can kind of start to make some assumptions of how some spaces work in a certain way and others as it went through. So it seemed to allow a way into the site. So as I say, it's a hard thing to kind of try and tap into. There's so many things going on to wrap your head around. It seems almost impossible, and trying to avoid falling into that sense of generalization. So it helped create what I call the river logic, and it was this longitudinal linear vector. So this river is a technical machine. It is there more or less purely for stopping the river flooding, doing things that, you know, engineering aspects wouldn't want it to do, i.e. taking out lots of housing. So things like the way the landform is formed, the trees, their densities, their grids, all of those things, the survey passages, they're all there for technical reasons. But yet, moving through them in a spatial kind of aspect, they do create something. And so it's actually, you know, helped kind of extract those out, and actually what forms this place from a spatial perspective, not just a technical one. And so this was just kind of, you know, taking all of that and actually, okay, what's the design query? How can I play with those experiences? You know, how can I really start to tweak and pull things like earthworks, those subtle shifts of what the landform do? How can I really actually start to maybe push them so it's quite contrasting, really starts to, you control someone's movement with earthworks, with trees, you know, path movements, edges, stop banks. How can it kind of take all those things that have been able to extract and put into a design method? So, hopefully I'm not losing you. So how is this drone useful to design? I will admit I did hit a bit of a wall when I was doing the thesis work at the time, that it was really useful data for analysis work in particular. But it was how could it then take all this kind of high level detail of information, you know, contour information, surfacing, and things like that. How could they then take that and actually make it transformable? It was quite a more difficult thing to kind of try and understand how to do and then actually do. So a mixture of digital softwares, plugins, and scripting actually helped shed the light on this. So software at the time just come out, which was a Grasshopper visual scripting software based called Bison, which worked in with Rhino 3D. And it was a landscape manipulation tool. I'm sure there's more and more now these days. As I say, this was almost 4 or 5 years ago. The visual scripting and AI tool sets have already come a long way. So I'm sure this is probably lots of other ways to do this now, which is really good. So this tool allows you to, I suppose, flip the current standard or, you know, traditional method of grading and shifting land. You know, it would normally come down to, you know, 2D sketching and drawing, and then kind of taking those, you know, on paper and then putting those into 3D and doing some testing. So what this allowed was you could then, instead of doing that, you could move straight into 3D. But it was like a live machine. It was, you could make changes and kind of see them update in real time. And so you could then test directly into the data set. So it could take the drone data, which is obviously a lot more detailed and accurate than other data that was available at the time. We could design it in that 3D dimensions at a level of detail that related to the bodily scale, which was obviously powered by the field study findings beforehand. And so as the designer, you're heavily involved in that process. There's no kind of jumping back and forth, 2D and 3D. You are designing in 3D throughout. So this is just an example of what the scripting could do. So as I say, a landform could be designed in 3D. It's dynamic, and it was a different way of designing and dealing with the land manipulation in particular. So I'm just going to jump to the video. If this works. So yeah, this is just a little simulation of what it was able to do. So that's drone contour information. I think it was 100 mil interval. So we're talking really highly detailed, because it needed to be almost that, almost so flat, so really detailed in its changeability, that data that was sparser wouldn't pick it up. And so then what we had the ability to do is, through these various tools, moving and shifting landform in a certain way, you could then push and pull the landform, or the contours in this case, to start driving different aspects and possibilities in the landform. So you can see there, starting to pull and push things with path alignments. You can make in plateaus, divots and all sorts, and you can control that by, you have the control of saying, I want something to be 5 meters wide, 10 meters wide, or 3 meters high down to 1 meter high. You can be extremely precise with your movements and what the landform can do. Make sure I'm shutting the right one. Sorry. So what that software process allowed me to really get into and interrogate, and again, as I say, especially being drawn from the field studies that I did as well, is that this is all a series of kind of design testing that was efficiently done. So this is looking at the changeability of the red block on the right hand side, which is that kind of dominant roading where cars are coming through. It's loud, it's noisy, it's not a particularly nice, kind of part of the landscape there to be in. And it was actually starting to tweak the landform in such a way that, depending on how far away in terms of the x-axis, how far away you move from the car, were you then kind of at a point where that wasn't really a dominant thing to you anymore, or also shifting it in the vertical aspect, moving it up, 300 mil, 800 mil, a meter, or the opposite, coming down into the landform, kind of really started to allow, these are all the potential outcomes of this, and this is just that one aspect of the user in the landscape next to a dominant car. This could then be used in the same manner for all sorts, in terms of the sensory of the river itself, landform changes within tree worlds, and as such. And so it allowed a real kind of power to very quickly, efficiently do these. So these are all just 3 iterations quickly pumped out, basically, as part of this testing. This could, if I recall, was done within a matter of hours, rather than days and weeks. And so you could then really start to understand, the little nuances in these subtle shifts. Let's make sure it's So these are some of the kind of wider design investigations. Oh yeah, 35 minutes, sorry. And yeah, so this was then looking at looking at those testings, what the landform does, and using the drone point cloud as a basis image. The contours are also based off the drone, and looking at how it works from a path perspective, stock bank perspective, and general landform. And this then kind of came together as part of the collective outcome, looking at the final design overall, which really dragged in the tree information, really dragged out before, contours, landform shifting, etc. And so this is some of the section work that really kind of were driven by this. You can see some of the kind of tree explorations, how that kind of came through into the design, and why and how those grids would strengthen up. They'd really tighten up to create really intimate experiences, and then open wide out when it was the right time and place to open out to the river. So this one being here, where a gravel bank, there's this really beautiful view opening out. And so here it seemed only to do justice to, minimize the amount of trees, gentle manipulation of landform, so the car it was nowhere near as dominant, and the river took the place. So these are just various some cuts through, and again that's just some of the processes through Grasshopper as well. So it's quite a meaty script. And again, some 3D model outputs were really useful too. Understanding it and actually physically holding it in your hand and looking at the contour information really helped kind of try and understand those subtle shifts, but what they do over a large scale really, make a big difference. And so you can see the whole kind of thing coming together there. My apologies, I've not been keeping an eye on my clock. So I'll just quickly go through some of the kind of commercial applications. Don't have the luxury of being able to take time looking through research and things like that as much in the commercial aspect. Time is money. And so I've had some intriguing examples where, again, there was a project on the Te Awa Karangi. It seems to be attached to my life, that place. And so as part of the design we were doing for the council, we were redesigning a 2 kilometre, 3 kilometre stretch of river. And again, trying to almost give it a bit of new life, very similar to what I was saying before. It was a stretch of 3 kilometres of path, some trees to the left, a berm and embankment to the right, and it really was just this kind of constant, very boring but also dangerous space where cars were using it at the time. And so this scanning came into effect for this project, not just at the drone scale, where we actually did a full scan of the site and used it again for aerial information and base topography works, but also did some scans of these concrete blocks, which again is part of the technical machine of the river. But we actually decided, look, how can we utilize these items on site that weren't getting used, and actually use them not just for the technical aspect, but also, interesting in terms of spaces, spatially, what they do, and kind of almost extracting some of those raw elements of this technical river and bringing them into the landscape design itself. So this block was scanned using the same process as the drone would, but with a mobile device. And so it went from sketch right through to model input through Rhino, looking at what we could do with the design, and then actually extracting that exact same element through the Revit process, and then actually into reality. So it's come out pretty well, I think. This rotation block design that we came up with, which was originally based off the point cloud model that we extracted. And the crucial thing with that is, because it's accurate in its relatable elements, we could take accurate dimensions off the block from the scan that then inform the model in Revit, and then which was based on in real life. And so when the real life things were coming into play, everything more or less lined up straight away, because those accurate measurements from the beginning, from the scans, really helped make sure that we were getting it right the first time. I'm not sure if that one's going to work. This is a scan from some of my colleagues that used for a design. So the UAV drone point cloud is on the left-hand side for a stream, and then on the right-hand side is the concept that my colleague came up with for the space. and that entire space driven on the right is all built off the point cloud on the left. So they used all of the elements, angles, slopes, the expanses of space, etc., based off the point cloud information they used in the design here. So there's a direct link of using the dry material as a base, which then derived the design intentions of what my colleagues came up with. So that was really useful to see how it kind of originated from. Show that video at the end if I have time. And then this is just also, again, this is all mobile scanning as well, not just drone scanning. So this is just scanning some data of areas that had never been scanned before. This is for my house back in New Zealand. And so it actually allowed me to have an understanding of what I had at the time and actually almost create a data source for things to come. We're looking at designing the back end of the house where it's very, very steep terrain, but there's no way that there'll be any decent survey data out there for this particular tiny spot. And so it just gave a basis to work off, just to understand how it could potentially terrace something. By no means is it highly detailed here, it's just indicative, but it actually gave me a base to work off to then start understand how could you make an interesting space just out the back. And again, this is just a project I did for my mum and dad earlier this year. It's a planting exercise for their new place. And again, there was no existing data. It was just quite handy to, it took me 5-10 minutes to quickly scan around this area, be able to take accurate measurements that are related in the model, and use it as a base to then quickly draw something up in CAD for planting, derive straight into an actual CAD planting plan, all driven off the point cloud created from the mobile scan, and then turned into reality. You can see the dog helping out there, into some planting, and ended up being really, really successful. It was quite efficient. Meant my father didn't have to do too much digging, additional work, because he knew exactly how much he had to dig based off the areas and what the point cloud data extraction gave us. So apologies, I rushed through the end of that. I lost a bit of track of time there, sorry. But no, thank you for your time. Hopefully that made sense, or some of it did at least. And yeah, welcome any questions.
Got the roof.
How do you store the point cloud data so that our computer doesn't die?
Did you catch that, Jacob?
Was that how to store the drone data? Is that what it was?
Yeah.
If you have the luxury, a nice big server, they tend to be pretty big data sets. I suppose, for when I was doing the especially my thesis stuff, I all mainly had it on a hard drive. Only need probably a couple of terabytes of space. So yeah, I mean, it does vary in size, but I wouldn't say they're monster big. Photogrammetry scans are nowhere near as big as LiDAR scans. So it kind of depends on what outputs you're getting from the drone, but it's not too bad. It's more critically the software and the computer's specs that can drive the information is the key bit.
Any other questions? I can throw one at you. How is shifting into commercial? How has shifting into commercial changed your, I guess, use of the drones or your outlook on it? Right, as you mentioned, you had kind of idyllicness of the studio, and then there's the pragmatism of
yeah, definitely found, obviously, I don't quite have the same, that same luxury to kind of, the time to test things out like that. And I was still very fortunate at Boffa that there was still the ability to kind of test things out as we went. But I certainly found in the commercial world, it's suddenly there's more than just your experience and opinion on how things might work. There's other people that are also doing this kind of work in various aspects, which is just a great learning curve. I had a fantastic mentor at Boffin School who really set me onto where I am now. And then also, I'd say commercially, if anything, it's perhaps more interesting because there's such a wide range of work. It's not just stuff that I've been, showing quickly today. There's all sorts of uses. There is the visualization side of things, photography itself, and just, the sites that it's taken me to in New Zealand for landscape architecture, planning, urban design cases really has, opened my appreciation up for, what a stunning country Aotearoa is, and what we can kind of capture with drones for our consultants as well as the clientele.
Last chance for a question.
I was just wondering, you use the 3D software on your phone? Is there like a specific app or something like that you use?
Yeah, there's a few apps out now, I think, but the main one that I used for what you saw on screen quickly is this one called Pix4D Catch. If you're quickly jotting that down, it is PIX4D and then catch, like catching a ball. And you can scan that, as I say, with your mobile of just whatever you happen to be scanning, and then you can process that on the computer with the Pix4D software. There is also, depending on what mobile device you have, I think, I'm not sure about Androids, but I can safely say for iPhones, iPads, if you look at the details of some of the newer ones, you'll see that actually they come with a LiDAR camera incorporated in the phone. And so you can then scan with your mobile device, getting LiDAR, it's obviously not highly accurate in comparison to LiDAR scanners, but it's still LiDAR. You can scan with your phone, not only photogrammetry, but LiDAR level data, which is quite handy.
Nice. All right, let's give Jacob another round of applause.